Hello, my name is David. In this video, I'm going to build a four-wheeled Rover robot. It has 4 independently controlled motors, 2 sonar sensors to avoid crashing into obstacles, and a webcam. I'm using electronic components from Phidgets Incorporated, including their SBC4, which is a single-board computer similar to the Raspberry Pi. Rovers are fun projects. They're inspired by the Mars rover and are far more capable than simple RC cars. In fact, you can consider this rover a mobile computing platform because the SBC is a full Linux computer. It has the capability to add image recognition for self-driving and steering around obstacles. As I continue to improve this build, I might add GPS and lights and maybe a speaker, and also more sensors to monitor the external environment. You could also add a robotic arm and use the rover to grab things and move them. In addition to the rover itself, I also wrote the control program using JavaScript. This program runs on the laptop and allows you to control the rover's movement with the simple Phidgets thumbstick control while monitoring the rover for motor speed and temperature overloads. I've posted a link to the GitHub repository containing the software in the description. This repository has a lot more details about the project. We're going to build a 4-wheel drive Rover robot using a frame from Servocity and using electronic components from Phidgets. The electronics components all are plug and play because of Phidgets' Vint controller design, which makes it very easy to program this robot to do what we want without worrying about low-level details. And also it builds very quickly because the Vint components just plug and play together. This is the frame we're going to use. It's from Servocity. As you can see, it's got nice big tires, nice soft tires. It's got a robust aluminum frame. This side of the wheels articulate, which means it makes a good ATV because it can crawl over small rocks. It's got a compartment here with holes for wires where you can put electronic components to keep them out of harm's way. And then each compartment has a door which we can use to, there we go, which we can use to keep dust and dirt out of those compartments. I've already wired up the motors, so those are ready to go. All we have to do is add the electronic components. This frame was pretty easy to build. It comes disassembled, but Servocity has a video that explains how to build it. And it only took a few hours to get this part together. So next, we're going to look at the Phidgets components and connect them together. Now we're going to look at the Phidgets components that we're going to use in this project, and we'll connect them all together. And then we'll run a system check to make sure that they're all working correctly. I like to do this before I mount them on the frame, because once they're mounted on the frame, it's a lot harder to disconnect and connect and rearrange wires and so forth. Let's look at the Phidget single board computer. This is the Phidget SBC4, single board computer containing everything you need to run a Linux operating system. Plus, it has 6 Vint ports. Each Phidget controller also has Vint ports, and you just plug the controller into a Vint port here on the SBC, and the SBC recognizes the controller or other device and knows exactly how to interface it. It saves you, if you're doing your own programming, from having to do a lot of interface work with the various devices. The SBC4 just takes care of it. This SBC also has a USB Wi-Fi dongle. There's a couple of extra USB ports, an HDMI port for video. This is where the micro SD card goes in, which is where the operating system lives. It also has an Ethernet port, which I needed when I first started working with it for initial setup, but after that everything is done by Wi-Fi. This is a very capable little computer, very easy to mount, makes a lot of your tasks a lot simpler. We're also going to include 2 of these sonar Phidgets. The sonar is sound, detecting distance by sound waves, and we're going to put one of these on the front, one on the back, and they will tell us if we're getting too close to an obstacle. In our program, we'll try to include some automatic shutoffs to the motors so that we don't crash into things. It will be a good collision avoidance detection system and will save us some accidents along the way. These are the 4 DC1000 motor controllers. I would have liked to have used smaller controllers, but I don't want to sacrifice these big motors, and these controllers are robust enough to handle the motors. You notice they've got fans to dissipate extra heat, which is really great. They have one drawback in that their size makes it hard to mount them. I'm going to have to figure out where to put all 4 of them on the chassis. And then they're powered by this LiPo 11.1 volt battery. I've wired in a switch here because these connectors are pretty hard to pull apart, and so with the switch we don't have to worry about that. Power for the SBC is going to come from this battery. The reason why I use a separate battery is that the motors draw current and it fluctuates quite a bit. We don't want the SBC to be subjected to that fluctuating current. I could have also used a voltage regulator, but I had the extra battery, so I'm going to do it that way. So now let's connect these up with Phidgets. It's absurdly easy to connect your devices. It's all plug and play, which is one of the things I love about Phidgets components and why I've continued to use them over the years. Okay, so I'm going to say ports 0 to 3 for the motor controllers. So I'm going to plug these into 4 and 5. Okay. Now let's wire up the motor controllers. I'm using a system just for my own memory where these 2 will be the left. This will be left front, left rear, right front wheel, left rear, right front wheel, right rear wheel. And the left front is going into channel 0, and the left rear is going into channel 2, which means that the left is the even numbers. On the right side, right front is going into 1, and right rear is going into 3, or the odd numbers. Now we can plug in power. And when we do so, I don't know if you can see this, but the red light turns on while it's booting. And as soon as it's done booting, it'll turn to green. And that's the way that you'll know that it's ready for action. And there it just turned green. And then all we have to do turn the switch on here. And now we can go to our computer and see if all 6 of these devices are showing up, plus the SPC itself. Okay, I'm at my computer now. I brought up the Phidgets control panel. And as you can see, it has already connected to the SPC through Wi-Fi. It found it automatically. I didn't have to type anything in. And it's there. And now we can go and we can check and see if our individual Phidgets are available. To do that, we click on this Phidgets tab here. And we can see the 6-port Vint, which is part of the SPC. We can see on port 0, a DC motor Phidget, port 1, port 2, and port 3, just the way we set it up. So that's good. Then on ports 4 and 5, we have the sonar Phidgets. Now, one of the great things you can do with the Phidget control panel is you can actually control the devices right from here without writing any code. So by clicking on DC motor Phidget, I see these various sensors and information panels that I can access. And the one I'm going to look at is DC motor controller. And this brings me up a whole panel where I can actually control the motor. Now, the most important one is velocity. I'm not going to do this because I don't have the motors wired in yet. We'll do this test later on. But as you can see, it runs from -1 to +1. And to make the motor go forward, we would just slide this over to the right. To make it go backwards, we slide it over to the left. That information comes into play a lot more when we're programming. And then down here we can see fan mode auto. We could change that if we needed to have the fans always running or always off. I'm going to leave it at auto for now. So that's what we can do with the motor. The temperature sensor is just going to tell us what the temperature is now on the device. And it's 20 degrees centigrade, which is probably pretty normal. That's what I usually see. We'll have to see how hot it gets in normal operation. Now let's look at the sonar Phidgets. These are taking readings. Right now they're upside down on my desk pointing at the ceiling, and it's telling me the distance is 1,630 millimeters or 1.63 meters, which is probably about right for the distance from my desk to the ceiling. And so that one's working. This one's similar. So we've got a good read on all our devices. Everything's working, and that's great. So now, this isn't the only way to access the devices on your SPC. Let's go over here. If I double-click on the Phidget SPC line in this display, this brings up the control panel for the SPC itself. There's a lot of different information given, a lot of settings that you can change. I'm not going to go into them all. But if we go to Phidgets, again, it shows us our attached Phidgets, the hub, the 4 motors, and the 2 sonars. If we go to Control Panel, we see a JavaScript representation of what we were just seeing in the other control panel. Again, it's the same information as before, just presented a little differently. But again, we can control the device from here. Now, the neat thing about this control panel and the other control panel is that the source code is available. I believe it's in the package that you download from Phidgets. If not, if you ask, they'll give it to you. And it's a great way to learn how to program these devices, because these panels do everything that you would want to do in your own software. So that's it. We've got a good test going. I think my next step is going to be to actually mount the different Phidgets controllers and the batteries in the chassis and wire up the motors and go ahead and do a motor test. I finished building out the chassis by adding all the components to the chassis and tucking in the wires and adding on-off switches, but there's still some wire tie downs to be done. I usually don't do that until the very end when I'm ready to field test in case connections come off or things have to be changed around that I didn't anticipate. So from the front here you can see the webcam on top. This is the sonar sensor, and this is one of the 4 motor controllers tucked in here underneath. If we turn it around to the side, you can see the second motor controller up here and controllers 3 and 4 down here on this rail. I didn't have any other place for these two. I don't like having them so close to the wheels because they'll get dirty if we run this outside, but I really had no other choice. On top you can see on-off switches. One is for the motors and the other is for the SPC4 single board computer. The battery for the motors conveniently fit right here in this slot. The battery for the SPC is here in the compartment. The SPC, you probably can't see, is underneath this battery. And then in the rear we have another sonar sensor. So that's the build. I'm going to work on the software now and then start testing out the various functions. So it should be fun. I've loaded up Visual Studio with the Node.js application. I'm going to click the debug icon and then launch program. At the bottom of the screen at the right, you'll see it starting up, and then it gives you the address to go to, which I'm going to highlight here. So then I go to the browser, then I type in http://localhost:3001. And if all is well, the Phidgets Rover control panel comes up. The big green button says connect to the Phidgets Rover. When I click it, the status light goes green, meaning that we are now talking to the rover. We can now use the thumbstick to drive the rover around, and you'll see the dials for the various motors are showing the speed at which the motor is turning, and also the temperature of each controller is displayed below the dial. There's a fail-safe built in, so if temperature gets too high, the rover will stop. So that's it. The rover is now fully operational. We're ready to display it proudly to our friends, and we're also ready to start dreaming of the next improvements to it. I hope you enjoyed this video. If you have any questions, let me know. And otherwise, I hope you have fun building your own Rover robot.